Okay, guys, in this video, an airplane is flying west at the speed of 425 miles per hour, and the wind is blowing northeast at 40 miles per hour. We want to know what is the ground speed of the airplane and what is the bearing of the airplane. So first of all, I drew the x-axis and y-axis so that they intersect at the 0 at the origin right here, okay? And so what we want to do is we want to come up with the coordinates for the first vector, which is the way the airplane was supposed to move. Let's call it v1. If the speed wasn't there, I mean, if the wind wasn't there, then it would just go west to the left, and the magnitude of that vector is 425. So this would be negative 425, 0. Okay, that would be v1. That's just the airplane if there was no wind. Now let's take a look at the vector v2, which is this one right here, right? This is the vector that shows you the wind. Now, why is it positioned that way? Because it says that it's blowing from northeast. So if this is, let's see, if this is like north, right? This is south, this is east, this is west. So the wind is blowing from the northeast. And so that's why the vector looks like this. Now, it has an angle of 45 degrees with the x-axis, right? So generally speaking, if you disregard which quadrant this vector is, then you just take the magnitude of the vector and multiply it by the cosine of the angle. So this would be magnitude is 40. We multiply that by cosine of 45 degrees. The other one, magnitude, is also 40, and we multiply it by the sine of 45 degrees, okay? Now, you should know, based on the unit circle, is that cosine of 45 degrees is square root of 2 over 2. And then sine is going to be also square root of 2 over 2. So this would have been correct if the vector was in the first quadrant, but it is clearly in the third quadrant where negative x and negative y, this is what we have to put, so that the negatives will be right here. Okay, so the next thing is to figure out what that course is going to be. But that's given by a resultant of the sum of these two vectors. So if you were to find the resultant and base it on the parallelogram law, the airplane actually is going to be moving like this. Okay, so there will be some difference. It's not going to go straight to the west because of the wind. Okay, so let's find this new vector. So this new vector is the sum of the two. So this is called a resultant. And we just add up, okay, whatever we got. So we got negative 425 minus 40. Well, 40 divided by 2, that's just 20. So that would be minus 20 square root of 2. That's the x component. And then the y component will just be negative 20 square root of 2. Okay, so in order to find the ground speed, we need to find the magnitude of this vector. So let's go ahead and do that. Okay, so I will use Desmos scientific calculator to compute it. So I take the magnitude, find the magnitude, I square the first component, notice how I'm putting it in parentheses, and then you can just drop the negative if you want, and then so square that. Okay, so that's gonna be the whole thing, but I need to take the square root of that, right? So so I got the square root, and then what I could do also, there is like a button right here called answer. So that just automatically copies the previous answer. So it looks like this is going to be the ground speed. So that's going to be 454.17, something like that, miles per hour. Now, the bearing of it, I think what they mean is the angle of this vector with the x-axis. So they're trying to figure out what that angle is. In order to do that, what you do is, so when you have two components, x and y, and you're trying to figure out the angle, let's call it alpha. This is going to be inverse tangent of absolute value of y divided by x. So this is something because the tangent of this, like if I were to create a triangle, right, and call this angle alpha, the tangent of alpha is going to be y over x, right, opposite over adjacent. So what I would need to do to find that angle, and I'm just going to pretend that both x and y are positive, even though they're negative, so I don't have to worry about which quadrant it is. I'll make a correction in a second, but let's go ahead and do the inverse. So I want to make sure the calculator is in degrees because they want me to put degrees there. So where is inverse tangent? If I go to functions, inverse tangent is right here. And I just need to take the y component I have over here. I don't really need the sign because it's absolute value. And then divide that by this guy. But I do not want the negatives in there, just the plus. Okay, so this should give me the angle. So the angle is 3.57. So the plane, what's going to happen is this angle is 3.57, but it's flying towards, I guess the bearing is going to be southwest, and the angle would be 3.57 degrees.